Hello, students. Welcome the Global Academy. I'm Shaikh sir and your chemistry educator. Today we'll study the MCQs for Karnataka CET on a topic Haloalkanes and Haloarenes. Now let's start with the first. The halogen derivatives of the alkanes are classified according to the nature of the halogen groups present in the molecule, the number of the halogen atoms in the molecule, the number of the pi bonds in the molecule, the number of the carbon atoms in the molecule. So, here, which is the correct option? Here, generally, the classification is based on the number of halogen atom in the molecule. How many halogen atoms are present? Based on that, generally, what were classified. So, the option, the B is the right option here, and the based on the halogen atom. So that's the question number 1. Now move to the second question. Primary, secondary, and tertiary alkyl halides are the types of derivatives of, okay, primary, secondary, tertiary. They are the derivatives of mono halogens, dihalogen, trihalogen, or tetrahalogen. And I think you know that in the theory already it is taught that they are monohalogen derivatives. They are the monohalogen derivatives. The primary, secondary, and tertiary are the monohalogen derivatives. So that is the question number 2. The third one is the general formula, molecular formula of alkyl halide is. The general molecular formula of alkyl halide is. I think everybody know that, and that is the D, okay, the CnH2n plus 1x. That is the general formula of the alkyl halide, and the right option is the D. Okay. Next is the question number 4. Which of the following is tertiary halide? Which one is the tertiary halide? What is the tertiary halide? The tertiary halide is this. This is the tertiary halide. The C, okay, CH3, CH3, CH3Br. This is the tertiary halide. And that is, what is the tertiary halide? It is 1, 2, 3, 4. It is a butane. It is a butane. So, butyl bromide, the tertiary butyl bromide. That is option C is the right option, and that is a tertiary butyl bromide is what is called as the right answer for this. Okay. Now that is the question number 4. Now the next question is, which of the following halide is the secondary? Okay, 2 degree is called as a secondary halide. Which is the secondary halide? So here you can see the 4 options: isopropyl chloride, isobutyl chloride, N-propyl chloride, and butyl chloride. So here this N is primary and this is also primary, so not possible. Now the question is the first and the second, A and the B. So we'll see the structure. First, isopropyl chloride. Isopropyl chloride is like that: CH3, CH, CH3, Cl. This is a isopropyl chloride. Then isobutyl is like this: CH3, CH, CH3, CH2, Cl. This is the isobutyl chloride. This is a isopropyl, okay, isopropyl chloride, and this is the isobutyl chloride. Now here you see this carbon, the carbon to which the halogen atom is attached. So this is a secondary, and this carbon, you can see there are the 2 hydrogens are there. So to which the carbon, the halogen is attached, and it is a primary. It is a primary carbon, and because of that reason, the right answer is A, the isopropyl chloride. That is the isopropyl chloride, and this is what is called as the secondary halide. Okay. The next is this. The number of primary carbon in the neopentyl chloride is. How many primary carbon atoms are present in the neopentyl chloride? So 4, 3, 2, 1. Now let's see first what is the structure of the neopentyl chloride. Neopentyl chloride is like this. Okay, this is a CH3. This is a CH3. This is a CH3, CH2Cl. So this is the molecule which is called as the neopentyl chloride. Okay, you can see that 1, 2, 3, 4, 5, 5 carbon. Okay, pentane, that is pentane chloride. Now this is what we called as neopentyl chloride. Then what is asked here? How many primary carbon atoms are there? How many primary carbon atoms are there? So this is a one primary, this is a second primary, this is a third primary, and this is also the fourth primary. So it is 1, it is 2, it is 3, and this is 4. So how many? Total 4 primary carbon atoms are there. So the option A is the right answer for this question. Okay. We'll move to the next. The IUPAC name of this compound. Okay, IUPAC name of this compound we have to write. What is the IUPAC name of this compound? So you see that the compound, I will once again write that compound here. Okay, it is a CH3, CH3, CH2, CH2Br. I think you know you have to number from this 1, 2, 3, 4. Okay, you have to number from 1, 2, 3, 4. So naturally, how it is here? 1 bromo 3 methyl butane. 1 bromo 3 methyl butane you are getting, and that is what is called as the B. 1 bromo 3 methyl butane. 1, 2, 3, 4. 4. So it is a butane. Hence the IUPAC name of this compound is 1 bromo 3 methyl butane. So that is the IUPAC name of this compound. Okay. Now let's see the next. Okay. The common name of 2-chlorobutane is. What is the common name of 2-chlorobutane? 2-chlorobutane. So how to write that? First butane you write. That is C. Okay. C. Now it is a 2-chlorobutane. 2 means the chlorine is on a second carbon. Right? It's a second carbon. That is a Cl. That is a Cl. So we can write that it is a CH3 H3. So what is the common name of this compound? Okay. What is the common name? So N-butyl chloride, no, it is not. The tertiary butyl chloride, no, it is not. The secondary butyl chloride, it is the secondary butyl chloride. You can see that. Carbon. You see the carbon to which the chlorine, the atom is attached. It is a secondary. This carbon is a secondary carbon. It's a secondary carbon. It is a secondary carbon. So it is a secondary carbon butyl chloride. So this is the way we have to find out the right answer. Hello students. Are you preparing for NEET, JEE or Karnataka CET? Looking for the right guidance to achieve your dream rank? Welcome to the Global Academy, the live coaching classes for the NEET, JEE and Karnataka CET, a single point and a complete solution for a competitive exam preparations, specially designed for the 11th and 12th or PUC first and the second year students, combining board syllabus as well as the entrance exam coaching. Our new batches starting from the 25th March 2026 for the academic year 2026-27. The course fees is 9,999. Now, with a 50% discount, you can enroll for just rupees 4,999 for the entire course. Limited seats are available, so enroll today. Call these numbers for enquiry, and you can also scan QR code for easy payment. Okay, we'll go to the next question. Okay, this is the next question. The IUPAC name of this compound. Okay, IUPAC name of this compound. Now, how to first we'll write the compound. Okay, I'm writing the compound. It is okay CH3 CH2, this group. Okay, then one more CH2, this is, then CBr, and this group, that is CH2 CH3 and CH3. Now this is the compound. Now important is that we have to numbering it. The number is very important. So we have to start the numbering from this. 1, this is 2, this is 3, this is 4, this is 5, and this is 6. This is the important one. Okay. Now this is the numbering. Now we can see that at third you have a bromo as well as the methyl group. So it is a 3 bromo 3 methyl hexane. So here the option, the A is the right option according to the IUPAC name. Okay, it is a hexane, so it is a 3 bromo 3 methyl hexane, and that is the 9th one. Okay, we'll go to the next one. That is the 10th one. The main difference in CX bound of the haloalkane and the haloarene is, what is the main difference between the bond between the carbon and the halogen in haloalkanes and the haloarenes? So first we'll write the haloalkane. Haloalkane is like this, that is this. So R, and one more we'll write H, and then this is the X. This is okay. This is the alkane, that is haloalkane. Then the haloarene you can write like this, that is a now here this is a sp3 hybridized, and here this carbon is sp2 hybridized. So the A and B, C, D, read that, and according to the what I had given the explanation, that haloalkanes, the carbon attached to the carbon sp3 hybridized, while in the haloarene it is sp2 hybridized. So that is the right answer is the B. In the haloalkane it is sp3, and in haloarene it is sp2 hybridized. So this is the question number 10. Okay, we'll go to the next one. Amongst the CX bound, where X is chlorobromoiodine, the correct the bound energy order is, okay, what is the relation between the bound energy and bound length? They are inversely proportional. They are inversely proportional. For example, we can write that, Okay, bound energy is inversely proportional to bound length. Bound length. So they are, if the bound energy increases, bound length decreases. If the length decreases, energy increases. So in this way, we have to know. So as you know that here, carbon chloride, carbon bromide, and carbon iodide, the bound length goes on increases and the bound enthalpy goes on decreases. Length, okay, length increases here, and the enthalpy, it decreases. It decreases. So here, okay, decreases or increases in this way, increases from. So the right answer, what is asked here? The bound energy order, the correct bound energy order. So we have to go for either this A, B, C, or the D. We have to see. So it is the this chloride to bromide to iodide. Okay, bound order, which is goes on increases here. Okay, that is the order, right order. So that is the question number 11. Okay, similar question, among the following bounds according to their bound length in ascending order. How to write the bound length in the ascending order? Shorter, smaller bound to the greater bound, or shorter to longer bound. So already I had told you the order is like this. So CF is the short bound length, then comes to the chlorine, then comes to bromine, and then comes to the iodine. Okay, as the size increases, because the fluorine to iodine, the size goes on increases. As the size goes on increases, the bound length is also goes on increases. Now we have to go ascending order, and hence it is carbon fluoride to chloride to bromide to iodide. So option A is the right option for this question. Okay. Next one is the chlorobenzene is. The four option has given less reactive than the benzyl chloride, more reactive than the ethyl bromide, nearly as reactive as methyl chloride, more reactive than the isopropyl chloride. Okay. Now here we can take the option. Actually, the option A is the right option. Why the A is the right option? I will explain you. We just see the figure. If you see the figure carefully, that is a Cl, this is a chlorobenzene, and this is benzyl chloride. Benzyl chloride. There are two things are there. One is this is sp2 hybridized, and this the carbon to carbon, the halogen is linked, which is a sp3 hybridized. That is a one. Now, as you know that here, as the chlorine is having the extra lone pair of electrons, this lone pair of electron, it gives to the what is called as the ring, and because of that is the partial double bond is forming, and because of that reason the chlorine atom is directly linked to the nucleus, the benzene nucleus, and because of that reason this chlorine is less reactive, whereas here the chlorine is not directly linked to this and it is sp3 hybridized. This chlorine is easily available for the reaction, and because of that reason the chlorobenzene is less reactive than the benzyl chloride, and that is the answer for this question. Okay. The 14th one, during the conversion of isopropyl alcohol to isopropyl iodide, which of the following is not used? Which of the following is not used? Option, carefully see the option. Okay, if you carefully see the option, the sodium iodide, potassium iodide, and the hydrogen iodide. So these all are using, but one which is not using is the C, which is with the sulfuric acid. Sodium iodide with the sulfuric acid is not used in the preparation of the propyl alcohol to iodide, because okay, it's a oxidizing agent here strongly, and because of that reason this is not using, sulfuric acid is not using. Okay, the next one is, name the major product formed when 2-methyl propane, okay, 2-methyl propane is heated with the bromine vapors in the presence of the sunlight. So this is the question. What is the main product? What is the main product is forming? Okay, I'm just writing the equation. Okay, is like this. So this is the 2-methyl propane. This is react with the bromine. React with the bromine in the presence of sunlight, H mu, in the presence of sunlight. What it gives? It gives this compound. This compound plus HBr it gives. Plus HBr. So you should know about this type of the writing also, the formula. Now, what is this? This is nothing but like this. CH3, C, okay, CH3, here CH we are writing, okay, CH, CH3. This is the one, plus Br, H mu, and this is also we are writing like this. It is CH3, C, CH3, CH3, Br, the main product. So this is the way we are writing here, and what you are getting here is you are getting this compound. You are getting this compound. Then how you will name that compound? How will name compound? So it is 2-bromo, okay, 2-bromo, 2-methyl propane, okay, 2-bromo, 2-methyl propane. Okay, that is the option A is the right answer, 2-bromo, 2-methyl propane. So here we can write any from this 1, 2, 3 or 1, 2, 3 we can give the numbering, and this is what you are getting, and that is this is a CH3, okay, this is a CH3, right, CH3. So this is the okay. So these are these few important the question of Karnataka CET on haloalkanes and haloarenes.